Now let's proceed to 5.7 analysis model, where we are going to consider the particle in equilibrium. The word equilibrium here means that it is in balance. When we have a concept of balance, it means that the net of the force on the system or the object that we are considering must equivalent to zero. Okay, that is the meaning of equilibrium. So when we do the summation of the forces acting on our object, it must equivalent to zero because it's balanced out. Right, so for the case of this, okay, candelier, this is a physical diagram. Okay, we can imagine that the forces acting on it is the tension. Okay, tension must be away from the object being considered. If it is not away, then it's not going to be a kind of tension, right? Then weight, it must be toward the center of the earth. Okay, so what we have here, all the forces are along y-axis. Right, that is why we are doing summation of Fy equivalent to, it is pointing upward. So based on our common sense, normally use upward as positive y, to the right as positive x. Okay, so T gonna be positive sign because it's pointing upward along positive y-axis. Okay, plus actually because we are doing summation of F along y equivalent to T, actually plus, but negative of Fg, weight, must equivalent to 0 because this is in equilibrium. So why is it the weight, okay, has negative sign? Because it's pointing downward, which is along negative y-axis. So from here, we can rearrange the equation. Then we will have T is equivalent to Fg, or weight, or equivalent to mg. So, okay, if there is a net force acting on our object, since the box here on the floor, there is must be normal upward because there is a contact surface touching here. Then, okay, this object also experiencing attractive force to the center of the earth, or also known as weight. And another force is applied by this man. So in terms of free body diagram, alright, we have normal, weight, and tension, okay, to the right. And this is our setting axis. Whenever there is a net force acting on the object, okay, it must be according to the Newton's second law. Summation of F equivalent to ma. So we are going to do the analysis on each of the components. So since for this case we have both y-axis and also x-axis, okay, the forces. So let's begin with the summation of Fx. Okay, what kind of force exists along x-axis? Only tension. So summation of Fx equivalent to T must equivalent to ma along x. So the a along x rearrange is equivalent to T over m. And now let's proceed to the y-axis. Okay, along y we have normal pointing upward, it's positive, and weight is pointing downward, so therefore it has negative sign. By right, remember we are doing summation, supposedly it should be add up. Okay, why is it become negative? Because of this, the direction of the Fg itself is downward and is equivalent to 0. How come? Because there is no motion along y. Okay, the motion only along x. Remember? Okay, the a only along x. That is why we know that the ay is 0. The a only exists in terms of x component. So for example, for this case, there is a book, okay, lies on the table, okay. We push down the book, okay. So the book has weight and also experiencing normal force upward and a push downward like this. First thing first, we're going to do the free body diagram. So we're going to list down all the forces acting on it. Right, this is normal, okay, and also weight. Confused? You can have free body diagram, okay, rearrange it. Have F downward, then you have normal upward. You also can put it like this, okay, weight downward. I think this arrangement gonna be better for you. And our setting axis, as usual, upward as positive y, to the right as positive x. So from here, okay, we're going to do the summation since all the forces along y-axis only, so we don't have to consider the x-axis, okay. So summation of Fy equivalent to 0 because the object, the book right now, is not in motion at all. So we have normal is positive, Fg is negative because it's downward, and also F is downward, so it's also negative. Sum of all of this must equivalent to 0. From here, we can have normal equivalent to Fg plus F, or any of the forces asked in the question. You can rearrange from here. Now, again, let's recall when we talk about the particle or our object in equilibrium, the sum of F net, okay, on the object must equivalent to 0. What does that mean? Based on this, okay, it brings us to that the A experienced by the particle or object must be 0. What does that mean by sum of F is 0? Should it be no force at all? No. Okay, for example, this object having mass of m. It has two kind of force, to the left and to the right, but the force is same amount, equal in amount, opposite direction. There are forces acting on it, but when you do the summation of F, or you are figuring out the F net on this object, the total of it is equivalent to 0. That is meaning, okay, the A must be equivalent to 0. How about there is a net force acting on our object, okay, according to this drawing or figure, okay. So you have an object with a mass of m, okay, having F net to the right, must be the A experienced by this object also to the right, because based on Newton's second law, sum of F equivalent to ma. So since the F is vector, the mass is a scalar, so the one that going to has the direction on this side is the acceleration. So the direction must be tally to each other or accordingly. So let's take a look on example 5.4, a traffic light at rest. Traffic light weighing 122 Newton hangs from a cable. So 122 Newtons is already the weight of the traffic light, okay. Tied to two other cables fastened to a support as the figure. The upper cable makes an angle of theta 1 equivalent to 37. Here is 37. Okay, and theta 2 equivalent to 53 degree with the horizontal. These upper cable are not as strong as the vertical cable, okay, and will break if the tension in them exceeds. So this is maximum, cannot more than this, then it will break. Okay, does the traffic light remain hanging in this situation, or will one of these cables break? So we know that here, since we have three different tension, so we have to consider part by part. First thing first, we have to consider, okay, the traffic light itself with the T3. And then after that, we're going to consider all of the three tensions. Okay, so first thing first, okay, for the traffic light itself, okay, it has weight downward, it has tension 3 upward. So from here, right, summation of Fi equivalent to 0 because the traffic light is not in motion. So T3 positive plus negative of Fg equivalent to 0. From here, T3 equivalent to weight of Fg, right? And for the other two tension, T1 and T2, we can transfer the information, okay, to this. Since just now, okay, if you still remember, okay, here is theta 1, right? So here will be theta 1. And here is theta 2 just now, right? So here will be theta 2. Now, let's resolve for the second diagram there. Okay, summation of Fy equivalent to 0 because it's static. Okay, what we have in terms of y, we have T3 is negative downward, okay, to the respect of this point. Okay, to the respect of the traffic light is upward, but to the respect of this type point it's downward. Okay, tension must always away from the point being considered. So now we have T2 plus T2, okay, component of it going to be here T2y, and here is T2x. So T2y is positive, but it's not simply T2, right? It must be T2 sin theta 2. For T1, the component of it, here is T1x pointing to the left, so it's going to be negative sign for it. And here is T1y, okay, plus, right, plus T1y. How to have T1y? We are going to use T1, okay, T1 sin theta, because to the respect of theta 1, okay, T1y is actually opposite side. Okay, try go a bit. Then what else? Do we have any other? Okay, we've done this one, we've done this one, and we've done this one. All of the y component mass equivalent to 0. Okay, so you may rearrange this equation according to what you have in your hand and what you want to solve for. Okay, have we done? Are we done? Not yet. Okay, we are left with sum of Fx equivalent to 0 because not in motion at all, static, completely static or stationary. So along x, what we have? Okay, we have T2, okay, x. Okay, how to have T2x? It's T2 cos theta 2, because to the respect of theta 2, T2x is adjacent side, right? And T2 is the hypotenuse, and it's positive. Why is it positive? Because it's pointing to the right of positive x, plus, okay, T1x. How to have T1x? T1, okay, cos theta 1, but it's pointing to the left, therefore it has negative sign. Is there any other component for x left? No, we've done with these two. Equivalent to 0. If you have two unknowns, you must have two equations to be solved simultaneously. If you have 3 unknowns, means that you have to have 3 equations to be solved simultaneously. So to ease the process of the sum, you also may put it like this, okay, in terms of table. Okay, this is better for resolving vector, right? Okay, so for each of the forces, okay, the vector, okay, list down the x component, the y component. When you want to do the sum, you directly put it here. Sum of f along x equivalent to sum of everything here. This one plus this one and plus this one equal to this one. Okay, and for this one, okay, summation of fy equivalent to this, let's put it, okay, this tick plus tick plus tick, and here is round plus round plus round. Okay, also can be done like this. It's easier actually. So it's actually the same to this, okay, which is I've done earlier before. So which one to be rearranged and what not, it depends on which unknown to be solved firstly according to the question. Okay, so the way to solve this one, okay, if you look at on the solution given here, okay, from here let's make the T2 as the unknown, right? And then from here we are using, okay, substituting T2, okay, into this equation here. You substitute this one, right? This is x component, equation from x component. This is equation for y component. Make the T2 as the unknown from x equation, then substitute into y component equation. Okay, so substitute it here, okay, and then you're going to simplify or solve for T1. You will get 73.4 Newton. Once you've done with T1, you may use either this equation or this equation again, okay, to figure out T2. Okay, you will get T2 for this example. We use this one, this equation. Substitute this value into this equation. You will get T2 equivalent to 97.4 Newton. So, does it exceed 100 Newton? No. So, it will remain stationary there. It won't break. Okay, so it is safe. Okay, suppose the two angles in the figure are equals. Okay, what would be the relationship between T1 and T2? If we refer back to the equation that already derived, that already relate T2 and T1, which is this just now, okay, and let's imagine theta 1 is the same with the theta 2. What will happen? This one going to be, with the value of it, 1. Isn't it? So it means T2 will be equivalent to T1. That will be the answer for the question. Right. Example 5.6, the runway car. A car of mass M is on an IC driveway inclined at an angle of theta, as in the figure here. Okay. Find the acceleration of the car assuming the driveway is frictionless. For the case of friction, later on we will discuss in detail, okay? Don't worry. So this is a physical diagram. From this physical diagram, we convert it into free body diagram, the FBD. This is the FBD, free body diagram of our car, where we have, okay, we list down all the forces acting on the car. So what we have here, so there is a contact between the car and the incline, so we have normal force, and also we have weight. Remember, weight always to the center of the earth. We have to understand that weight is coming or exists due to the attractive force between the mass of the car and the mass of the earth. That is why the weight always at the center of our object and to the center, pointing to the center of the earth. Okay, it's not a must. Again, I'm repeating here. It's not a must for the weight to be opposite in direction to the normal. Okay, if you put the weight is here, okay, it's completely wrong. Okay, completely wrong. Remember that, please. Normal is always perpendicular, 90 degree to the contact surface, but the weight must always to the center of the earth. Alright, so from that, is there any other forces acting on the car except normal and weight? No more. How about this? This is actually component of the FG or MG. So here, this is FGY, and here we have FGX, right, which is equivalent to mg sin theta. Okay, how to transfer the theta? Okay, you can deal with the theta. We can prove that theta here is the same to this theta. Okay, that is how we know that this is mg sin theta and here is mg cos theta. Do not memorize. For y component, it must be sin theta. Okay, for x component, it must be cos theta. No, it's wrong. It depends on the component that we want to determine, or we don't know, the unknown, okay, whether it's adjacent side or opposite side to the angle. Because we are using sin, cos, or also tangent can be used. Okay, so do not memorize, you have to understand. Right now, from the free body diagram of our car just now, we are going to do summation of fx equivalent to max. Okay, because we know that the car is in motion. Okay, so summation of fy equivalent to may. Okay, firstly, put both of the a, because we don't know which a is 0. Okay, if you are not sure, you just simply put everything, presume that all of it has value, right? So from here, okay, mg sin theta, which is this component, is the only force along x. That is why, okay, we don't have any other force, equivalent to max. From that, the m can be cancelled out. Okay, so we know that the ax is equivalent to g sin theta. Okay, for y component, okay, you have normal, okay, pointing upward, so it's positive, plus negative of mg cos theta, because it's pointing downward, must equivalent to ma along y. So from here, you will get, okay, could be n, if you are interested in n, or if you are interested in a, ay equivalent to n minus mg cos theta over m. Right. B. Suppose the car is released from rest at the top of the incline, and the distance from the car's front bumper to the bottom of the incline is t. Okay, how long does it take the front bumper to reach the bottom of the hill, and what is the car speed as it arrives there? Okay, so means that it's from, okay, rest. Okay, so v initial is 0. The car is already traveling d distance, okay, until the front bumper reach the bottom of the hill. Okay, so we need to figure out v final of the car. Okay, So it's involving kinematics slightly here, where we have delta x. Okay, this is the original. Delta x is equivalent to Vx initial t plus half ax t square. So what does that mean by delta x is x final minus x initial, okay? So equivalent to all of this, right? So from here you rearrange x initial to be placed at this side, okay? You will have this kind of equation. Now, okay, our x final is x final minus x initial is actually the d. This is the distance travel. Okay, and we start from rest. So v initial of the car is 0. Okay, that is why we are left with d equivalent to half ax t squared. Okay, so to figure out the time, okay, we rearrange this equation. It's going to be 2d over ax equivalent to t squared. So square root everything, left and right, you will get this equation. Okay, to figure out the t, the time taken, to reach d distance, okay, from starting point, right, when it is released from rest. And to figure out the final speed of the car, Vx final squared equivalent to Vx initial squared plus 2ax delta x, actually. So our delta x is the d, right? And our v initial is 0, starting from rest. Okay? And this one is the d. That is why our equation become or simplified to this. Okay? So from here, to know the v final of the car, okay, along x, is going to be 2ax d. And our a, x just now, is coming from previous solution. Here, ax is equivalent to g sin theta. Substitute it here. You will have this kind of equation. Alright, don't worry. We will do exercise that having values for this and this. Okay, inshallah you will understand more. Right, what previously solved problem does this situation become if the angle is 90 degree? The angle of theta become 90 degree. How is it? You just imagine. The angle here become 90 degree. So, it's like this, isn't it? So, the angle here become 90 degree. So, the car going to experience, the car going to be like this. Okay. What does that mean? Free fall. Okay. The A is exactly equivalent to the G, to the center of the earth, which is 9.81.